Welcome to my YouTube channel. Let's look at this physics question on projectile motion. A bullet is fired in a horizontal direction with a muzzle velocity of 300 meters per second in the absence of air resistance. How far will it have dropped in traveling a horizontal distance of A, 20 meters, B, 40 meters, C, 60 meters, and D, how far would it drop in 1 second? Let's draw out the given parameter. So given fired, bullet is fired with a horizontal velocity u is equals to 300 meters per second. We are asked to calculate the height at a range A is equals to 20 meters, B is equals to 40 meters, and C is equals to 60 meters. And we are also asked to calculate the height at time equals to 1 second. That is time of flight is equals to 1 second. Let's take G to be equals to 9.8 meters per second. From our previous class on projectile motion, we said that we make use of the horizontal velocity only when considering the range, which is the horizontal distance. And if we are to solve the maximum height, we only consider the vertical motion. So before we can find the maximum height, we have to find the time at a horizontal distance of 20 and for 40 and for 60 before we can find the height for each range. So if we are to consider the maximum height, we will use the equation of motion, which says that S is equals to ut plus 1 all over 2 at squared. And you know that we can also use this to calculate the range. But for range, we know that the horizontal acceleration is equals to 0 since the velocity is constant. So range will now be ut. This is what we use to calculate for the time for this before we can find the maximum height for this. So let's look at when the range is equals to 20 meters. When range equals to 20 meters, say that range is equals to ut. So 20 is equals to the horizontal velocity 300 times the time. So if we are to make the time the subject of formula, we have 20 divided by 300, which is equals to 0.667 seconds. With this, we can calculate the maximum height for this range. So our height from this equation of motion will now be equals to ut plus 1 all over 2 gt squared, where the initial velocity for the vertical will be equals to 0 since it is falling from rest. So 0 times 0.667 plus 1 all over 2 times 9.8 times bracket 0.667 all square. So when you press your calculator, you now have height is equals to 0.222 meters. This is the height when range is at 20 meters. So let's calculate when range is at 40 meters. When range is equals to 40 meters. From here, arrow is equals to UT, which is 40 is equals to 300 times the time. So when you make T the subject of formula, T is equals to 40 divided by 300, which is equals to 0.0133 seconds. For us to find the maximum height at range equals to 50, we make use of this formula. Now the h is equals to initial velocity, which is 0, times the time, 0.0133, plus 1 all over 2 times 9.8 times bracket 0.0133 all square. If you press your calculator, now the h is equals to 0.087 meter. This is for the maximum height when range is 40 meter. Let's calculate for the maximum height when range is 60 meter. So for range is equals to 60 meter. Say that arrow is equals to UT, which is 60 is equals to 300 times the time. For us to find our time will now be 60 divided by 300. This cancels this. 6 divided by 30 is equals to 0.2 seconds. With this time, we can find our maximum height using this equation of motion. Therefore, h is equals to initial velocity 0 times 0.2 plus 1 all over 2 times 9.8 times 0.2 all square. When you press your calculator, h will now be equals to 0.196 meter. So that is for maximum height when range is 60 meter. So let's calculate for the height at the time equals to 1 second. When time is equals to 1 second. With this, we can calculate our maximum height. Using this equation of motion, we also have h 0 times 1 plus 1 all over 2 times 9.8 times 1. So 2 here we have 1. 2 divided this, we have 4.9. 4.9 times 1 plus 0, h will now be 4.9 meter. These are the answers to this question. Please click on the subscription button to get more questions on Projectile. Thank you.